Hey guys, another problem of equilibrium into the sorry says the lift sling is used to hoist a container having a mass of 500 kilograms. Remember, we have to convert that into weight. Determine the force in each of the cables AB and BC as a function of this angle. That's the first part of the problem. That will be part one, and this will be part two. If the maximum tension allowed in each cable is 5 kilonewton, determine the shortest length of cables that can be used for the lift. The center of gravity is located here. Okay, several things. Basically, if the center of gravity is located here, the weight, which is 500 times 9.81, is going to be assumed to be there. 500 times 9.81, 4,905 Newton. Now, just imagine that you are cutting this thing here. You're looking at this thing from here, and let me forward this thing right there. Yes, here and there. It's obvious that the value that this force will be uh, holding has to be the totality of this weight. So basically, we can put here 4,905 Newton as the value for this F in this case. Rest of that, everything is symmetric, meaning this angle is equal to this angle. And if you do particle equilibrium at A, we will have 4,905 Newton, and then you will have this tension and this tension. This is tension AB and tension BC. Let me put it like that, even though I know that you know, or you should know. But if I do right now summation of forces in X equals 0 in this particle, what I get is negative AB cosine of the angle plus AC sine of the angle equals 0. That's what you get, cosine of the angle, equals 0. Cosine of the angle. If I divide everything by cosine, this and this cancel out, this and this cancel out, this is 0, and AB equals AC. This is just a proof. I know you knew it, that by symmetry, this tension and this tension, if the angles are the same, should be exactly the same tension. Has nothing to do with pulleys. When you have pulleys, the tension has to be the same tension in one side and the other side, irrespective of the angle. But this is not a pulley. This is a ring. This is a ring right there. But because the angles are the same, this force and this force are the same. So the first part of the problem, I'm gonna call them T. So the first part of the problem basically will be done doing summation of forces in Y equals 0. And if I do that, remember we call this T. So basically it will be T, these two components, this will be T sine of the angle and T sine of the angle. So basically it will be T sine of the angle, negative because it's pointing down, minus T sine of the angle, negative because it's pointing down, plus 4905 equals 0. Negative T sine of the angle, negative T sine of the angle, that's basically 2T. So I can pass this to one side and say T is going to be equal to 4905 divided by 2 times sine of the angle. And you can express this equation like that and say that determine the force in each the first one, AB and AC as a function. Okay, this is the tension as a function. Yeah, you can call this cosecant if you want to, and simplify this too, but I'm okay with that because I don't like this type of problems like that. I like more engineering-wise problems. So now the second part is interesting. If the maximum tension allowed in each cable is 5 kilonewton, determine the shortest length of cables that can be used for the lift. Remember, this angle could change, and it's probably we will probably have different possibilities for that inclination when we calculate this. Now, the second part of the problem will be something like this. I'm going to solve this for the angle, and I will say sine of the angle equals 4905 divided by 2 times t. I just pass this here and this here. And t is 5 kilonewtons. 5 kilonewton means 5,000 newtons. So the sine of the angle will be 4905 divided by 2 times 5,000. That will be sine of the angle 4905 divided by 10,000. 2 times 5,000. 0.4905. Okay. I remember in a different problem I was telling you something like that I used to remember in what quadrant the sine and the cosine are positive, because you can have several angles here. So then I do something like this. You see sine and cosine. And then I check. When I check sine, I know that the sine is going to be positive here and positive here and negative here and negative here. And the cosine is going to be positive here, negative here, positive here, and negative here. Now, the sine is going to be positive in these two quadrants, in the first quadrant and in the second quadrant. Let's see if I get sine of theta equal that. Let me get the inverse of sine to calculate the angle. The angle that I will get is 29.37 degrees. Any angle that is bigger than that one is going to give me a larger length. But anyway, let's say that I don't know how much is that. Then the other angle will be in the third quadrant, in the second quadrant here, and then you will have this 29.37 measured like this, and the angle will be this. That means 180 minus that. 150. Those are the two possibilities. 150.63. Look, if I take sine of this angle here, just to check with this, sine of this angle here is the same, you see? 0.4905. 0.4905. Now, I'm just doing this like that. I know the answer is going to be this, but sometimes the problem asks you for different angles for different answers. Mathematically, these two answers are correct. Engineering-wise, this is the only possibility, because if the angle that I'm calculating is 150, well, I don't know. It would be something weird acting in that direction. So this is going to be the angle that we are looking for. The length is easy. How do I calculate the length? I need this height. I can say tangent of the angle is equal to y divided by this, and calculate y. Or I can say that the cosine of the angle is what? Is 1.5 divided by the hypotenuse, which is the length. So the length is going to be 1.5 divided by cosine of that. 1.5 divided by cosine of 29.37, and that will be 1.721 meters. That would be your answer number 2. This simplified, of course, will be the answer for the first part of the problem. Okay? I hope you like it. This is the simplest way that I can find to explain you this. Oh, there's another way also. Once you establish this, in terms of this sine and cosine here, you could also take the derivative and make the derivative 0, and then find the angle for that derivative equals 0, because that's going to give you the shortest distance as well. But as I told you, I don't like going into the math that much. I like using the math, but basics of the math that I need to use. See you next problem, guys.